Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 25, 2026, about 5 days ago. It presents a fully automated framework that leverages test-time compute scaling strategies, specifically universal self-improvement and a new method called T-rank, to produce high-quality translated benchmarks that preserve original task structures. The paper is titled, Recovered in Translation, Efficient Pipeline for Automated Translation of Benchmarks and Datasets. And as we'll see later, the resulting improvements in multilingual evaluation reliability are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 2 illustrates the T-rank workflow, which is designed to select the best translation while neutralizing positional bias. The process begins on the left, where a translator model generates several candidate translations from the original text. To ensure fairness, these candidates are shuffled into every possible order before being presented to a judge model. The judge ranks these permutations, and the system calculates an average score to determine a clear winner. Finally, as shown on the top right, the best candidate is polished one last time to fix any specific flaws. While Figure 2 focused on ranking, Figure 1 illustrates the universal self-improvement workflow. This method is distinct because it doesn't just select a winner, it synthesizes a new one. The pipeline starts by sampling multiple candidate translations from the source text. Then, a judge large language model evaluates the entire set to extract the most accurate phrasing from each. Finally, it aggregates these pieces into a best combined translation that surpasses any single draft. So, having seen the workflows, Table 1 presents the actual translation quality scores using the Comet metric, which evaluates accuracy against a human reference. The authors test on two datasets, WMT24++ and Flores. We see that advanced methods like best of n, universal self-improvement, and T-rank consistently beat the baseline. Specifically, T-rank achieves the highest score of roughly 0.85 on WMT24++. In contrast, on the Flores dataset, universal self-improvement edges out the others. This split in leadership hints that the best approach might vary slightly depending on the text complexity. Alright, having established the translation quality in Table 1, Table 3 now quantifies the impact on actual model performance. The authors re-evaluated mid-sized models on these improved benchmarks and compared the scores to existing baselines. The column on the right shows the average improvement. Winagrande sees the largest gain of about 3.4%. The paper suggests this happens because the new translations fix grammatical cues that used to accidentally reveal the correct answer. ArcChallenge and Hellaswag also show clear improvements, confirming that higher quality benchmarks provide a fairer test of model capabilities. So, while the previous table focused on downstream scores, Table 2 evaluates translation quality directly using an LLM as a judge. Here, Gemini 2.5 Flash compares the new translations against the standard global MMLU baseline. For Ukrainian and Romanian, the T-rank method achieves over 8,000 wins, vastly outnumbering the losses shown on the right. The trend continues for Lithuanian, where the universal self-improvement method secures over 7,000 wins, confirming a strong preference for the new pipeline. Well, to illustrate the answer leakage issue mentioned earlier, Table 6 compares a flawed baseline translation against the corrected version for a Winagrande task. On the left, the bad example shows how the verb form accidentally reveals the answer. In Ukrainian, the neuter verb ending matches the neuter noun for bed, but clashes with the feminine noun for blanket, allowing the model to cheat using grammar alone. On the right, the good example fixes this by masking the specific suffix. By including all gender options in parentheses, the text hides the grammatical cue and forces the model to actually reason about the context. Wrapping up, two takeaways stand out. First, applying test-time compute strategies like T-rank and universal self-improvement significantly boosts translation reliability. Second, without high-quality localized benchmarks, we cannot accurately measure progress in multilingual AI. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.